Okay, so in this one, we're going to look at 8.4, logarithmic and exponential functions. And I'm going to do this as a part 1, part 2. This is outcome R10. Now, when we're solving these equations, we're going to notice that there are a few different cases that we're going to have to deal with. So I'm going to talk about this one as being case 1. So notice how we have everything is in base 2. Our logs are all in base 2. And then we've got 3 different arguments. So let's try to combine them and see what we can do. So let's call this case 1. And that's where we have a log with something plus a log with another argument equals a third log and argument. Okay? So what we're going to do is let's simplify where possible. Okay? All right, so here we can use, which law is this going to be? The laws that we did yesterday? The quotient? So log base 2, x minus 2 on the top, and then divided by x is equal to log base 2, 3. All right, so now once we have the equations, are log something equals log something else, we can drop our logs. Okay. All right. I'm glad you think that's funny. So now pretty much what we're going to do is we're going to notice, since these are the same base logs, we're going to look and see what is going to make these 2 arguments equal. Okay? So solve the arguments. Okay, so we're going to solve the arguments. So how do I isolate x here? Multiply x, multiply x. So I've got this x cancels with this. I've got x minus 2 equals 3x. And then solve for x. I've got an x here. Subtract x on both sides. Negative 2 equals 2x. X is equal to negative 1. Okay. Now, what I need to do is I need to verify this in the original equation. So I'll write step 3 here. Solve for x in the arguments. Solve for x in the arguments. And then once I've done that, I need to verify the solutions. Okay, verify the solutions. So go back to the original equation, which is log base 2 x minus 2 minus log base 2 x equals log base 2, 3. And plug in that value of x. So I've got log base 2 negative 1. If I put a negative 1 here and a negative 1 here, I get negative 3 minus log of negative 1 equals log of that. Now, how can I combine these 2 together? What do I notice about this right here, actually? Notice anything? What can I notice about my argument? Arguments are negative. Does that pose a problem? Yeah? So since that's non-permissible, right? It's beyond our domain. It doesn't work. There's no solution to this. There's no solution to this. So what I'm going to say here is that this has to be rejected. So there are no solutions. No solutions for this. And just to talk about our domain, just remember that the argument has to be positive. Not only positive, it has to be greater than 1. Okay? So we can also check the domain of this up here and notice that x minus 2 has to be greater than 0. And we need x to actually be greater than 2 in order for it to be a valid solution. And we end up getting x is negative 1. So x, a negative 1 is not greater than 2, so that there's no solution. So there's a number of ways that you could show that there's no solution to this. Okay, so now example 2, it's a different case. So notice we've got the same base here again. You've got log something plus log of something else equals a number. Let's call that case 2. Okay, so what log law can we use to combine these two together? So same as before, we can simplify. When they're adding, what can we do to the arguments? Multiply them. So I can write this as log base 4 and then 11 minus x times x plus 6, and that's equal to 2. And what do you think we're going to do to this here? Yeah, so you can multiply that together. So we've got 11x plus 66 minus x squared minus 6x. Okay. All right. Now, once we get, notice how we've got that simplified and we've got log something equals a number. Now, can we change this to another form? Do you recall another form? Change this to exponential form. So what is this going to look like if I have this in exponential form? So 4 to the power of 2 is equal to the argument here, right? Are you guys okay if I simplify this and rewrite it nicely down here? So what is it going to be? So negative x squared plus 5x, and then plus 66. Okay, so what is 4 squared? So now I've got this equation here, right? What does this look like? Quadratic. What's going to happen now? Set everything over to one side, make it equal to 0, and solve for x. How do we solve for x? Factor x squared, and then minus 5x, and then minus 50. So negative 66 plus 16 is minus 50, right? Okay, and then we can take this, factor it. What do we end up getting? So 5 and 10, which one's positive? The 5 is positive here, x, and minus 10, x. So x is equal to 10, or x is equal to negative 5. Okay, so I've got two solutions. Step 3, what did I, oh, I already did step 2, step 3, so then what comes after 3? 4. Okay, so we solve for x, and then the last thing, what do we need to do? Verify. Okay, so let's do our verification and make sure everything balances out. So all we need to do is really make sure that our arguments end up being positive. Okay, so what do we end up if we plug in for 11 minus x and x plus 6, that's what we need to verify. So I've got 11 minus 10, that's 1, so I'm okay. And then I've got 10 plus 6, which is 16, so that's good. And then I've got to do it with my negative 5, so I've got 11 minus negative 5, which is 16, that's good. And then 10, no, x, 5 plus 6, which is 11, negative 5, which is, sorry, 1. So it's greater than 1, so I'm good. All right, perfect. So yeah, both solutions are legit. All right, now there's a couple of questions on the flip side here, which are your turn questions. So I'm going to hit pause and I'm going to give you guys a chance to try them right now. And then we'll come back and finish, show you the answer, and then come back and finish case 3, okay? Sound good? Okay. Okay, so now let's get back to let's just go over these questions. All right. So we're looking at this one here, right? Now this turns out to be the case 1 question where you've got log plus log equals a log. So you want to simplify it using your log laws, and we use the quotient law on the left side here. And then once we got them both equaling logs, now we can drop our logs and solve for x. So the next step is to simplify, solve for x, and then we've got a simple quadratic that we can factor. And once we get that, we end up getting x equals negative 3 and x equals 2. And we need to verify that our arguments all end up being positive numbers. So the only one that actually works in this case is x equals 2. We can see in the very first argument, x, it's just x. And if I plug in x equals negative 3, that makes that argument negative. So that's, I don't even need to check the other arguments. I can just say it doesn't work, it's gone, okay? So we can reject that solution there. And the only solution actually ends up being x equals 2. All right, so there's the solution for that. And now the next one is we've got, this is case 2. We've got a log, and a number. But we have to rearrange it in order for it to actually look like the example that I did previously. So now I've got my logs together on one side. I can use the product law in this case to write it as log something equals a number. And then I can simplify my argument here. Then I'm going to rewrite it in exponential form. And I've got a simple quadratic, and I can solve for x. Now, some people might also notice that this can be written as log 6 base 6, okay? And you can then have your log equals log, and then you could drop the logs and solve the arguments there. That's totally fine. That works, gives you the exact same answer, okay? So once we get to our quadratic, factor it to negative 6 and negative 1. Then you want to verify your arguments. So my arguments in the original question were x plus 3 and x plus 4. I can very quickly see that if I put in an x equals negative 6 into either of these, it will not work. It'll give me a negative number, and I can't have a negative argument. So the only solution is x equals negative 1, because when I plug it in here and here, I end up with a positive number for my argument. All right, so that's it for that. Okay, I'm going to do the next part in another video, so stay tuned, folks.